Hey guys, welcome back to AlgoYogi. We are doing graph series, and the next problem in the list is reorder routes to make all paths lead to the city 0. So let's go to LeetCode and give this problem a read. There are n cities numbered from 0 to n-1 and n-1 roads such that there is only one way to travel between two different cities. Now last year Ministry of Transportation decided to orient these roads in one direction because they are too narrow. Now roads are represented by this list, 2D list connections, where there are values like tuple values A to A and B, where there is a road from A to B. It is city A to city B. Now this year there will be a big event in city 0 and many people want to travel to this city. Now your task consists of reorienting some roads such that each city can visit city 0 and return the minimum number of edges changed. Alright, so right now there are roads from one city to another, and these all the cities are connecting, but you cannot reach from each city to city 0 because the roads are one directional. Because they were too narrow, Ministry decided to change them just to make them one directional. Now our job is to flip those roads so that every city has a path to leading to city 0. And then that's what we return. We will return the count, how many roads we will be flipping. All right, so let's go over this example. Right here we have 6 cities. So we have 6 cities. And since there are 6 cities, there have to be 5 roads. That was given in the problem. So there are 5 roads. Right now we are given connections. This is a list that contains these tuple values where the values is A and B, and that means there is a road from A to B. All right, so if we go over these connections, we can just directly see that if we go over a first value, so 0 to 1, that means there is a road from 0 to 1. There is a road from 1 to 3, and 2 to 3, 4 to 0, and 4 to 5. All right. Now in this network of cities, what we need to do is we need to find if there are paths, direct or indirect, from all the cities to city 0. So right now if you see that city 4 has a path to city 0, but city 1 doesn't have a path to city 0. So that is why we are flipping this particular road. So this will be this road we are cancelling, this road right here, this road right here we are cancelling, and we are flipping this. Then there is no road from 3 to 1, so that is why we are cancelling this road and flipping it, because the roads are just one directional. You can either have just, from city 1 to 3 or city 3 to 1. So it's just a way of like changing the traffic. You're not flipping the roads, it's just you're changing the traffic. That only traffic that can flow is from 3 to 1. And then there is already the road from 2 to 3, so that is why, see, 2 can travel to 3, and 3 people we already flipped. This city has a path to 1 and 1 has a path to now 0 because we also flipped this one. So that is why we flipped these 2 roads. So we have flipped 2 roads, and then here we don't need to flip this one from 4 to 0 because there is a direct path, and then from 5 to 4 there is no road, so we will flip this one also. We'll cancel this one and flip. So there are basically 3 roads that we need to flip. So we need to flip the traffic of these 3 roads. All right, but if you see right here, what are we going to use? BFS, DFS? Well, right now we can't use anything because in this graph, in this network of roads, we can't really traverse from, if we start at 0, we can go to city 1 and then we could go to city 3. So only these 3 cities I can traverse. I have no path going to 4, no path going to 5. So if I was starting at 0. So even if I start with any city, I do not have the ability right now to travel to basically all the cities. Let's say even I start at 3, I cannot travel anywhere else. So what I need to do right now is I have to create 2 directional roads between these two, between all the roads right here. Right, so what I'll do is I will create, there is already a road from 0 to 1, but I'll create a road from 1 to 0. Then I'll create a road from 3 to 1, and then there is a road, I want to create a road from 3 to 2, there is a road from 4 to 0, so I'll create a road from 0 to 4, and then a road from 5 to 4. Now right now you can stand on any city and then you can go to any other city. So if I stand, like, let's say 5, there is a path to go to 4, and then from 4 I have a path to go to basically this one to 0, 0 to 1, 1 to 3, 3 to 2. So now I can stand on any of the city, and I have the ability to go to any other city. What I can do right now is, while I was creating these two directional, what I was really doing is I was creating this graph adjacency list. Graph adjacency list. So what I was doing is actually, so I was checking that all these cities 0, 1, 2, 3, 4, and 5, and then we're gonna have the list of cities they are connected to. So 0 was connected to basically 1, so there was a road from 0 to 1, but then I want to have a road from 1 to 0 as well. So what I'll do is, next to 1 I will add 0. Be careful like what we are actually doing here. We have all these list of nodes that we can visit from basically these nodes. So we're going through our connections. We're going through our connection one by one. Although it's a different thing when you are seeing things in graph, but when you actually are thinking in terms of list and like these tuples, you have to like basically think it in terms of like grid, right? So right here we are going one by one. So we are done doing basically this. We're done doing this. So 0 to 1, 1 to 0. So we're basically adding from path from, if there is a path from 0 to 1, we are also adding it to 1 to 0. And then there is a path from 1 to 3, so I'll add 3 here. And then there should be a path from 3 to 1, okay? Then there is a path from 2 to 3, so 2 to 3. So these are neighbors of 2, or all these neighbors. I'm just collecting all these neighbors next to each of the city. Then there is a path from 4 to 0, so 4 to 0, so I'll add 4 also to 0 because I'm creating all these bidirectional roads. There is a path from 4 to 5, so 4 to 5, so I'll add 4 to basically next to 5. So this is what I am done creating. This I have just created. Let me see if I did this one correctly. This one I have not, since there was a path from 2 to 3, so 3 to 2. Okay, now it's all good. So there is a 3 is in 2's path and 2 is in only basically 3's path. So this is basically the adjacency list that we have just created, and we'll also create this as like a set, also a set. Now what I want to do is I want to find out the number of roads that I will be flipping. And what are the roads that I'll be flipping? I have all these bidirectional roads. So now every city can visit 0. So I just want to see what were those roads that didn't exist when we couldn't visit basically 0. So what I'm saying is there were some roads that were present earlier that could lead to 0, but there are roads that I have just added that couldn't earlier made it possible for me to reach 0, but now I can. So what are those new roads that I've just added? So if you see what are those roads that I've just added? So well, one could not reach 0 earlier, so I have added this one. This is the road that I've just added. Then I have added this road. Well, 2 could reach 3, so I didn't need to add this, so this is kind of like extra. But then 4 could reach 0, so I didn't need to add this one, but then this one I needed to add. So there are basically 3 roads that I have just added which were not present earlier. Now that's the number I will be returning. So what I'll do is I'll use a BFS approach. So I'll have a queue. Initially my queue will have 0, and then I'll start my while loop, basically exploring all the neighbors of 0. What are the neighbors of 0? Well, these are the neighbors of 0. These right here are the neighbors of 0. So I'll go to 4 and 1. So I'll go to basically 4 and 1 right here. So 1 and 4, these are the neighbors I'll be visiting, and then I'll be asking if these roads from basically neighbor, so these are the neighbor to node, so neighbor to node, so 1 to 0 and 1 to 0 and 4 to 0, these two roads, what are the roads that are not present in my connection? So 4 to 0 is present, 4 to 0 is present, but 1 to 0 is not present. Although there is 0 to 1, but 1 to 0 is not present. That is why my count will be 1 now. Okay, so I'm done visiting these. Then I will append these two neighbors to basically in my queue, so that I can visit now like the other cities. Then I'll start exploring the neighbors. So 1, the only one neighbor is 3. Well, now we'll check. Was there the road basically from neighbor to this node 1, so 3 to 1, was this present in my connections? Well, no. So I'll again add this to my count, then I'll add 3 to basically my queue so that I can explore it. All right, so I can explore it. So 4 and 3. Now 1 is, we are done visiting 1, so let me clear this up. Then we will be popping out 4, so we are visiting 4. 4's neighbor is 5. Was there a road present from 5 to 4 was in connections? Well, there was a road from 4 to 5, but not 5 to 4. So what we'll do, we'll add one more to my count. So that we will do with all the cities. So we are like using DFS to visit all the cities, and then we are increasing my count if the road basically in these new roads, I will be checking from neighbor to the current being visited node. If that particular tuple was not present in my connection, then I will basically add that to my count, I would say. So couple of things, we will be maintaining a visit set to track that we are not, because these are bidirectionally connected. So if we have visited something, then we don't want to visit it again. So basically what I was saying is, like right now if I'm visiting 4, I have already visited 0. 0 is also a neighbor of 4, so I will add 0 in the beginning to my visit set, so that I'm not like finding myself in a loop where I'm just going over and over between these two nodes. So I'll have a visit set, then I'll create a set of all these values, so that I can in constant time I can check if this value is present here, this new road that I'm creating. If it is not, then I will increment my count. So right now I think things are very clear. If you want to like just go over it again, let's just simply go over it. We will create this adjacency list where we will have the connection created from each of these roads to basically the neighbors. So if there was a road from 4 to 5, we will create a road from 5 to 4 that will allow us to visit all the cities. Once that's done, that means we have added some new roads that made it possible for visiting all the cities to 0 or any other node. Then what we want to do is we only want to count the road that were not present in my connections. Given that while I was visiting these roads, well, this road didn't exist. This road didn't exist, but I don't need to actually count it. Why? Because I don't need this road. While visiting basically 3, because there is already a road that was present in my connections. Okay, let me just like write the code, and then it will be like super quick for us to understand things. So we'll use DFS. You can also use DFS. It's easy peasy. Now let's create this graph ADJ list. Initially, it's going to be basically a dictionary, and then I to this will store the neighbors. I is the node or city for, let's stop using these I's and all. Let's use city for city in range n. All right, then we'll have basically a city set of cities to check what are the roads that are present in this city set. So for you can also simply just add a connection right here, but I'll add it later. So what I'll do now is for A and B, these are the roads in connections. So this graph adjacency list will have basically A dot append. So we are adding B to A's neighbors, and then we'll add B to A's neighbors. Okay, creating two directional roads, B to A's neighbors. Awesome. And then we'll also add A to B as this road into my basically city set, A to B. So there is a road from A to B. That's what we were doing. Now let's create a queue, DQ. That's the inbuilt data structure in Python. Now DQ, we're gonna start our traversal at 0. We are exploring from 0, so that is checking that what are the neighbors of 0, and then from those neighbors, was there a road to 0? And if not, then increase my count. So count will be initially let's say it's 0, and then we'll start our while loop. While q, let's pop the node. So q dot pop left, and then for also visited set. Let's not forget, because this will be, these are all like all the cities are connected to each other. So if 0 has 1 and 4 as its neighbors, then 1 and 4 are going to have 0 as their neighbors. So we don't want to stuck in the loop while, since we have already, once we visit one node, then we want to just put it in my visited set. So node, and let's add it to my visited set. Visited dot add node. Now let's explore all the neighbors of node. So for node in basically not this graph adjacency list, that's where all the neighbors of node will be stored as a list. So now we are exploring not the nodes, neighbors. What I want to do right now is if this neighbor is visited, so if neighbor in visited, then I'll continue. No loops. Then there is one more thing. Now is when I want to check if there was a road already present from neighbor to the current node that I'm visiting, and initially I'm starting with 0. Would this road, if this road is not present, not in my city set, if this is not in my city set, then only I want to increment my count. That means I will be flipping that road. I don't have to actually flip it, but I'll be flipping it. Okay, and that will be it. But before we actually move out, we want to append this neighbor. If this has not been visited and there was basically made a decision if I need to flip it or not, I will be exploring that neighbor later. So what I want to do, I want to append it to my queue. So we'll have append just neighbors. I don't think we have to add it as a list or anything. So this is it. And then finally I will be returning return count. Okay, so let's zoom out and you can see the code right here. So this is it. Simple code. I know the video might be long, but like what I have realized so far, like all these graph videos are like becoming really long, and I'm spending a lot more time and energy just solving these problems, and that's because like they actually deserve your time and energy. And once you spend a lot of your time like solving one problem, that makes it easy for you to solve the next problem, because later like once you go through the concept like in your mind, that really strengthens the idea that will be used later to solve the next problem. So right now, like it doesn't take me any effort to basically write the BFS or create the adjacency list. If you do that over and over again, you will not forget about visit set. You will not forget about like using a BFS or DFS, which will be easier. So that is why we are making these videos longer, but that is only going to help us later. Okay, yeah, like we don't have to get through quickly just to forget it next week. Okay, so now let's basically run it on our examples. There is a little mistake right here. It has to be this bracket, not square bracket. That was my bad. Let's run it again. And yes, awesome. Let's submit it. Great. Okay, so let's write down the time complexity, which is going to be big of n. N is the total number of nodes we will be visiting. All right, so here the queue will be going over all the nodes we will be visiting, because all the cities have to visit city 0. So that is why our time complexity is n. N is the total number of cities. Then what about the space complexity? Well, we are creating this adjacency list. We will be storing all the neighbors of each city. So at max we are kind of storing like our size would be 2n, because each city is being stored for like its neighbor, and that neighbor will have that city for itself. So we can just simply write space complexity will also be big of n. All right, awesome. Let's go back to AlgoYogi, mark this out, and see you guys later in the next problem.